All right, welcome everyone. Grade 7 learners, get ready because today we are diving into an absolutely epic exploration of the very lifeblood of our planet. In this explainer, we're going to unpack the phenomenal forces that power literally everything around us. Think of this as your cinematic guide to totally crushing your upcoming science and geography exams. So let's jump right in and uncover the secrets of our world, one energy source at a time.
I mean, think about it for a second. Absolutely every living thing, from the tiniest little insect in your garden to the tallest tree in the forest, needs an energy source to survive. But, it's not just living things. Look at all the modern machines we rely on, our cars, our smartphones, those massive industrial factories. Every single one of them is just hungry for power. So we really have to ask ourselves, where does all the energy that powers our entire world actually come from? How does our planet store it? And how on earth do we harness it? To answer that, we're going to follow a quick 4-chapter roadmap for your test day success. We'll start with the power of our planet, move into the buried giants, check out the forces of nature, and wrap it all up with the ultimate energy scorecard.
Okay, Chapter 1, the power of our planet. Let's lay down the basics. Before we can even begin to understand the complex machinery of global energy, we have to establish our core building blocks. I need you to lock these two fundamental definitions in your brain for your exam, okay? Literally all energy sources fall into one of two main camps. First, we have renewable energy. These are sources that can be reused, recycled, or just naturally replaced by the Earth as quickly as we use them. Think of things like sunlight or wind. On the flip side, we've got non-renewable energy. These exist in a strict, limited supply. Once they run out, that's it. There's going to be absolutely nothing left, because it takes way too long for the Earth to replace them. Which brings us to Chapter 2, the buried giants. Let's talk non-renewables. For this, I want you to imagine traveling deep, deep beneath the Earth's crust, away from the sunlight, down into the dark, silent depths, where ancient, finite power sources have been waiting for millennia. Down here, we find fossil fuels. It's actually kind of mind-blowing. The fuel we rely on today is the result of an epic, million-year transformation of the buried remains of prehistoric plants and animals. We rely heavily on these buried giants across the globe because, right now, they're abundant and relatively cheap. But make no mistake, they will eventually run out. And worse, burning them releases harmful greenhouse gases that seriously pollute our air and change our climate. So for your test, you need to know exactly what these fuels are. There are 3 main fossil fuels you gotta remember. First up is coal. This is mostly burned in massive power stations to generate electricity or used in stoves for heating. Second is crude oil. This one's the heavy hitter. It's packed with energy and gets refined into petrol, diesel, and petroleum so we can fuel our cars and trucks. And third is natural gas. This gets trapped in deep underground rock formations and is widely used for cooking, heating, and also generating electricity. But hey, fossil fuels aren't the only buried giants down there. Let's talk about nuclear energy. Instead of burning ancient plants, nuclear power harnesses energy from intense nuclear reactions using a mined mineral called uranium. Now, because uranium is in a limited supply on Earth, nuclear energy is classified as non-renewable. A really proud, massive local example of this technological feat is South Africa's very own Coburg Nuclear Power Station. And Coensberg brilliantly illustrates what an incredible double-edged sword nuclear power really is. On one hand, it is spectacularly efficient. A tiny amount of nuclear fuel produces a colossal amount of electricity, and it creates absolutely zero air pollution. But on the other side is a pretty terrifying reality. It produces extremely dangerous, deadly radioactive waste. This waste is so harmful to living things that it literally has to be sealed in special containers and buried deep underground, where it takes hundreds of years to break down and actually become safe. Plus, just building these plants is unbelievably expensive. All right. Let's head back up. Chapter 3, Forces of Nature. Time for renewables. Ascending from the dark underground, we are bursting back onto the vibrant surface of our planet to witness the endless, dynamic energy of the natural world. Let's kick things off with the sheer force of water, hydroelectric power. The mechanics here are wonderfully simple, but they are incredibly powerful. Step 1, you need a continuous supply of fast-flowing water, usually from a steep river or a massive dam. Step 2, all that rushing water physically pushes and turns these massive mechanical turbines. Step 3, those spinning turbines are hooked up to a generator, which, like magic, well actually, scratch that, it's just physics, churns out electricity. Now, because South Africa has pretty intense dry seasons, large-scale hydro requires a lot of continuous water. We actually import a ton of power from the massive Cahora Bassa Dam in wetter Mozambique. But locally, we do have some seriously impressive structures like the Gariep and Vanderkloof dams on the Orange River. While water power is perfectly clean, reliable, and renewable, we have to remember that building these colossal dams costs an absolute fortune, and they can significantly disrupt aquatic life and river ecosystems.
Next up, we're harnessing the invisible power of the sky, wind power. Picture the sweeping, relentless winds of the Western and Eastern Cape catching the giant, graceful blades of wind turbines. A spectacular local example is the Jeffreys Bay Wind Farm, sprawling across 3,700 hectares. Wind is fantastic. It's abundant and entirely free. However, to actually capture it, you need strong, regular winds, which makes picking the right location absolutely critical. On top of that, constructing these giant turbines is really costly, and some people find wind farms to be pretty noisy and visually intrusive.
Okay, prepare yourselves for a truly staggering number, 300. That is the number of days of pure, brilliant sunshine South Africa is blessed with every single year. That makes us an absolute global powerhouse for our next energy source.
Solar power. Using photovoltaic cells, solar panels literally absorb the sun's rays and convert that immense energy directly into electricity. South Africa is completely capitalizing on this with massive projects like the Solar Capital DR farm up in the Northern Cape. And what's fantastic for us is that solar power gives homes and businesses a way to gain real independence from the national grid, directly helping South Africans combat load shedding. It's free fuel, zero emissions, and super low maintenance. Though, of course, it doesn't work so well on cloudy days, and you definitely need expensive batteries to keep the lights on at night. Our final force of nature is biomass energy. This is a wonderfully clever way to recycle. Biomass basically turns natural materials like plants, wood, crop leftovers, and yes, even animal dung, into power. Organic waste can be rotted down to create biogas, or crops like maize can be turned into liquid ethanol fuel. An amazing real-world example of this is the Cape Dairy Biogas Plant in the Western Cape, which literally turns agricultural waste into usable energy. But biomass requires a very fine balancing act. On the positive side, it brilliantly cleans up agricultural and landfill waste. And unlike fossil fuels, we can grow new plants relatively quickly to replenish our supply. However, if we get too greedy and harvest biomass without care, it can quickly lead to devastating deforestation and the destruction of natural wildlife habitats. It has to be managed really carefully.
All right, home stretch, Chapter 4, the ultimate energy scorecard.
This is where we bring everything together for your definitive exam review. Take a mental screenshot of these comparisons. Let's weigh them up. On the renewable side, your pros are that they are clean, sustainable, and the fuel is provided completely free by nature. The cons, they are often totally weather dependent and come with huge initial setup costs. On the non-renewable side, the pros are that they provide highly reliable, steady energy, and the infrastructure is already well established and relatively cheap to run right now. The heavy cons, they will absolutely run out, and they are the primary drivers of pollution and climate change. Which brings us to arguably the most important vocabulary word of our entire expedition: sustainable. To be sustainable means using our planet's resources to meet our current needs without damaging the environment and without depleting those resources so much that future generations have nothing left. It is the absolute ultimate goal for the very survival of our beautiful planet.
So, as we conclude this explainer, I want to leave you with a final thought. You now possess the knowledge of the buried giants and the forces of nature. As the next generation of scientists, geographers, and leaders, which forces of nature will you champion to sustainably power our future? Keep that curiosity alive, best of luck crushing those exams, and I'll catch you on our next incredible journey.